All right, so we have log base b as in boy of y to the fourth times z. So there are several properties that we're going to use here for this particular example. If you notice, we have y to the fourth times z. So we know that we're going to use the product rule, but this base y is raised to the fourth power, so we're going to also use the power rule. So let's first use the product rule. So we have here log base b of y to the fourth plus log base b of z. So we use the product rule where we're going to add, and then secondly, we're going to use the power rule for the first log, where we're going to take the 4 and bring it in front of the log base b of y. So we have here, our solution is 4 times log base b of y plus log base b of z. And there we go. Next example. Log base 6 of the square root of x all over 36. So we have a fraction, we have a quotient, so we're going to use, first of all, the quotient rule. So let's do that. Log base 6 of the square root of x, and because we're using the quotient rule, we're going to subtract, minus log base 6 of 36. Now this square root of x, let's convert that to an exponential expression. So x to the 1/2 power. So I'm going to rewrite this square root of x as x to the 1/2. Log base 6 of x to the 1/2 minus log base 6 of 36. Now, because we have a base raised to a power, we're going to use the power rule, where we're going to take the 1/2, write it in front of the log base 6 of x. Now, let's look at log base 6 of 36. Let's see if that can be we can write that in simplest form. So let's take that component, set it equal to x, and write it in exponential form. So we have 6 to the x power equals to 36. My question to you is, what is x? That will be 2. So log base 6 of 36, that will give us the solution of 2. So our answer here is 1/2 times log base 6 of x minus 2. Okay, let's do another example. Okay, so here we have log base b of x squared y all over z squared. Let's do that first example. Okay, so we're going to use all 3 rules. We have a product, we have a quotient, we have a power. So what is first? We're going to apply the quotient rule. We have log base b of x squared y minus log base b of z squared, and this is a 2. Then let's use the product rule where we're going to add. So converting this first log here, we have log base b of x squared plus log base b of y, bring down the minus log base b of z to the second power. And then lastly, for our exponent of 2, for the base x here, and we have z, we're going to use the power rule. So we have here 2 times log base b of x plus log base b of y minus 2 times log base b of z. And there we go. Our next example. Let's go ahead and take, as we look at this, we have log base g of the square root of x times y to the 7th all over z to the 9th. Let's go ahead and convert this square root of x. So we have log base g of x to the 1/2 times y to the 7th all over z to the 9th. Now that we've converted the radical to an exponent, we're going to pretty much follow the same steps as we did in the last example. We're going to use the quotient rule first, the product rule second, and the power rule third. So let's start. Quotient rule first. Log base g of x to the 1/2 y to the 7th minus log base g of z to the 9th. Then the first log, we're going to use the product rule where we're going to add the logs. So we have log base g of x to the 1/2 plus log base g of y to the 7th. Then bring down the minus log base g of z to the 9th. And then lastly, we're going to use the power rule where we take the exponents and bring it down in front of each log. So we have 1/2 log base g of x plus 7 times log base g of y minus 9 times log base g of z. And there we go. Now we've taken this log and we've expanded this log. Okay, where it was small, now we made it larger. Now in the next video, we're going to do the opposite where we're going to take an expanded log and condense it.